your bottoms up sheet, it lists out the steps of factoring. Our first step is always, is it your first step? That one's already done. And then we need to look for GCF, so the greatest common factor. So what can I factor out of the first one? What do they have in common? A 3 and an x. So what's left on the inside? Negative 16, right? Okay. So once you have the GCF out, it looks like the difference of squares. Do you guys remember what the difference of squares layout is? You've got two factors.
Y.
So you have a y minus and a y plus. And then the square root. So that's the 4 and 4. Now it doesn't say to solve, so you wouldn't move on to step 9 on your paper. It's not setting them equal to 0. That would be your final factored answer. Try number 2 on your own using that bottoms up method. We're looking for factors of 30 that add up to negative 13. So since 30 is positive and our middle number is negative, what do we know the signs are going to be? It's going to be two negative numbers. Anyone found those factors yet? Negative 10 and negative 3. So we set up our parentheses. Yeah, x minus 10, x plus 3. We're not done yet, though. We need to do the actual bottoms up part of bottom up. So we take our a value and divide both of these.
Because AC is positive.
Thank you. So x minus 10 divided by 5 simplifies really nice. So it's just the x minus 2. However, x minus 3 over 5 doesn't simplify to a whole number. So that's our bottoms up. We take our 5 and bring it up front to our coefficient. And it is completely factored. Now, number 3 looks like a difference of cube, but what do we need to do before we factor? Need a GCF. So, what's our GCF going to be? 3x, which leaves us on the inside with minus. That's that difference of squares again. You're going to have 1 plus and 1 minus. The square root of x squared gives us x. And the square root of 9 gives us the 3. This is a super common mistake. A lot of people just put that as their answer. Is that right? What are they forgetting? Bring down your 3x. Even though you factored it out from the beginning, it's the greatest common factor. So you still need to bring that down. And the last one, try number 4. So, good GCF, but kind of in a basic simplifying thing, we could divide each term by 3x. So that would be the 12x cubed divided by 3x. Plus the 9x squared divided by 3x minus the 15x divided by 3x.
Is that a negative 3?
No, I'm sorry. My pencil is. Yep. So if your divisor goes evenly into each of the terms, you could break it down like that, but that's not always going to happen. So this one give you 4x squared plus 3x minus 5. This is like one of your elementary school problems. Long division will always work, even if the divisor doesn't go evenly into the dividend. So you can build your house, put the divisor on the outside, dividend on the inside. And then, how many times does 6 go into 42? Multiply them together. And then subtract. Of course, those cancel because we set it up that way. Bring down your 9. How many times does 6 go into 9? Multiply them together. Subtract. Bring down your last. 7. So it gives you 716 with a remainder of 1. Okay. We're going to make that a little more challenging, add some variables into it. So you're going to need to know this vocabulary. What's traditionally on the numerator is the dividend. Again, probably learned this like 10 years ago. Then the divisor is what's going on the outside of the house. So on the outside of the house, you have x squared plus 2x plus 1. Draw your divisor bar for your dividend. 2x cubed plus 5x squared plus x plus 3. And when you're doing this, you're looking at the leading term. So how many times do I need to multiply x squared by to get 2x cubed? 2x times. And then when you're multiplying through, you can multiply your 2x times each term. So 2x times x squared gives you the 2x squared that or cubed, we wanted. 2x times 2x is a positive 4x squared. Then 2x times 1 is positive 2x. And be careful when you're subtracting down, you're really distributing it. Okay. So these cancel out like we planned. 5x squared minus 4x squared equals 1x squared. And then x minus 2x, negative x. You bring down what's left. Great. And do it again. So, super simple, x squared times what gives you x squared? 1. So that multiplication just kind of brings down your divisor. When you subtract down, these cancel. Negative 1x minus positive 2 leaves you with 3x. 3 minus 1 is 2. Now what can I multiply x squared by to get negative 3x? What can I multiply x squared by to give me negative 3x? You can't. So that is our, what do we call this? Our remainder. This, your 2x plus 1, would be your quotient. You're going to have to kind of label those. So when long division works all the time, this only works when this has a coefficient of 1. The only time it will work. Okay. So to find, you'll set up each synthetic division problem like this. You'll draw a box, a line, and another box. That tells you what you're dividing by and what your remainder will be. So to find this box, you're going to set your divisor equal to 0. Super simple algebra 1 problem. You have x is equal to 2. You add 2 to both sides, addition co. And this is what goes into the box up here. So then you put the coefficients of each term lined up in line with your box. So it's 5, negative 13, 10, and negative 8. When you're putting those coefficients up there, you really, really, really need to be careful that you have every single term. So that means you have an x cubed, an x squared, an x, and a constant. If there was no x squared, what would you do? Put a 0 in there as a placeholder. So our first step is to bring down the first term. You're always going to bring down that first one. You have 2 times 5, 10. Sorry. 2. Write down 5 equals 2 times 5 is 10. You add down. So negative 13 plus 10 is negative 3. 2 times negative 3, negative 6. 10 plus negative 6 or 10 minus 6, 4. And then 2 times 4. When you add those, you get 0. So they're always going to give you this order. It goes remainder, constant, x, x squared. If you still had numbers, it would just go up by 1. X cubed, x fourth, and so on. So your final answer would be 5x squared minus 3x plus 4 with no remainder. This one doesn't look like how you would normally see a division problem, but what do we know about our negative 1 exponent? It's going to put it on the bottom. So really, instead of having negative 1 up there, you could write n plus 2 down here. So I would start with a box, a line, and another box. So that kind of reminds me that there's going to be a remainder. So using our order, it goes remainder, constant, m squared, m cubed. So you have m cubed minus 5m squared plus 10m minus 15. And then our remainder is 24. So if you have an example like this where you have your remainder, your constant, x, x squared, and x cubed, you can just ignore the zeros. Okay? They don't want 0x plus 0x squared. Okay? So kind of just gets repetitive.